Hello, brother. My name is Monish, and today you're gonna be learning to make stuff that will hopefully someday resemble something like this or like this. So, today you're gonna be taking your first step towards that kind of a goal, and I'm going to help you start up by teaching you how you can draw a few things. And we're going to start from actually level 0, meaning I am going to assume that you are a little dumb kid who has no experience with all of this. Maybe triggering, but if you accept this fact, you can really work on changing it. So, right now, we're gonna take to the tablet and you're gonna see me teach you. In like 3, 2, and 1, we're gonna go. Hello, brother. This is going to be a candid session where I'm going to sketch things out on the Concepts app and teach you stuff. So, if you really want to make the best out of this experience, I highly suggest installing Concepts or just using whatever software you have with you, or just in general picking up a pencil and a pen, or a pencil and a paper. Yeah, that's more appropriate. Now, let me actually start a drawing. Let me make a new folder, by the way. First, I'm going to start by teaching you the few basics. So, I'm going to assume that you know what shapes are. That's a fair thing to assume, right? Let me draw something that's a little bit more skewed. This is something like a rhombus, or like a parallelogram, if that's what you'd like to call it. This is all fine and dandy, bro. Show us the real candy, you ask. Well, let me show that to you in a little while. First, let me show you how you can break down an image, and for that, I'm gonna go and get an image and be right back. Yeah, brother, do you like this work? This seems a little bit too complicated for us to start with, but let us think of something else to actually draw today. These are all like my stuff, so you don't really have to worry about getting copyrighted if you draw them out today. So, what do we pick? There's a lot of options. I'm going to say we're just going to pick something in random. I'm going to close my eyes and scroll, and I'm going to touch something. Oh, this is Kipo. Today, we're going to be breaking down this boyo. He does look very bulky, so first I'm going to teach you how you can use those basic shapes we were talking about. And first of all, what you do is you draw a round for the head, and you actually break down a trapezium at its mouth. And then what you do is you actually draw another shape which kind of circulates through the whole thing's body. This is in more of a dynamic moving pose. I will try to do that as well. So this is another shape that the artist has employed here. These two are ears. I know this looks like it could be something that's bought from Walmart, but still, it works. So, hey, this technique works. What do you do then? Well, you draw another shape and you break down its nose. Another more shape and you break down its eyes. And hopefully, you just build up the image starting from there. So that is how you break down something by the use of shapes. And what I'm going to be teaching you next is how you can take this to the next freaking level. Because 2D is really cool. Like you can draw all of the stuff. But where's the actual depth? Where's the actual fliff and fluff? Well, that's in 3D. So when do we get to the good part? Well, that's when we actually get to 3D. I know it's not really looking anything like the image on the right, but this is just barely a breakdown that I did in a minute to show you something. And hopefully I did. You just keep breaking down shapes. Like for the legs, look here, more shapes. And once you've broken down enough parts, you'll be able to draw anything that you see. That is the first thing we actually learned today. And from basic shapes to constructions, you just keep breaking down and you're gonna get better at copy drawing. If that's for you, You've already got your words now, so you might as well leave the video, right? Well, that's where you're wrong. I have more for you. So, you know how shapes aren't just 2D, they can also be 3D. Did you know that? Like, I didn't know that at first. When I was a little child, drawing a little sun at the corner of every image I did not know that. And look here, bro. Yep, my mom called me for milk. I just went downstairs and came back up. And look how 3D this shape looks, by the way. Okay, all of that's fine and dandy, bro. We got you on that. But how the hell are you making this little thing look like that? Well, brother, that is what form is. So, in 3D spaces, there are basically three rules that you have to follow while constructing in them. Like if one object is in front of another and they're both of the same size, say this boyo and this boyo are like 20 centimeters and 20 centimeters, and they're both placed in a manner where like one's behind the other, what happens is this thing looks smaller than this thing. You can even observe it in reality right now. Just let me take another picture to show you actually. This is like old traumatizing shit. Yeah, this is like a Boruto manga cover. No, we didn't come here in need of that. Yeah, Minecraft. So you see this house over here, right? How is this house smaller than that house? Although they are both the same size. I said the same thing in reverse, but you get the point, right? What you do is, when two objects are of the same size and they're put back, one appears to be smaller than the other, right? So what happens if you draw a line from the top of one thing to the top of another, and the top of another thing to the bottom of another? Oh, they seem to converge. What does this mean? Well, this means all parallel lines in our reality, when they're a little bit skewed, like when you look at them in a slightly tilted angle, like what we are doing right now in Minecraft, like this little bit of a curve here and here, like you see here and here, right? What happens is they basically go to one point, and everything in the middle they follow. Like if I put a line through this and this, they follow back, and if I put a line through this and this, they follow back. But what does that have to do with things becoming smaller, you ask? Well, brother, if parallel lines are parallel, let's just say a cube is present in front of you. Like, let's say, preferably it's a Rubik's Cube. Let me find a picture of a Rubik's Cube for you. I probably have one lying around. You know what? Screw it. We're gonna use something different. I did not find that. Now, look at this thing. Over in this image, you can find one thing, right? Like, there is this box that is an image, and everything seems to be going inside. Like, take this pillar over here, for example. When it's placed at the back, it appears to be a little bit smaller, right? So, as a result of these parallel lines, when they are ever so slightly skewed, meeting at a point, what happens is the entire thing goes back and back and back and makes stuff smaller as they go backwards. And now, if you're like, bro, then how do I calculate distances correctly in the perspective grid? First of all, this does not have any connection to do with that, but I'm gonna answer that question anyway, brother, because I brought it up and I want to answer it. So just say this is the image of concern, and let me just draw something. First of all, let me draw a line here, and second of all, let me draw this thingy over here, like this thing. And now say I wanted to have a grid where all the stuff in the grid were actually equal. What would I then do? Well, I'd first do one thing, that is, I'd find a random pattern and I'll just stick it on top of everything. This is not a professionally working method, but it happens to get the job done if you want to show stuff that becomes smaller as stuff goes back. This especially does work for such circumstances. And there's a specific reason behind it, but if I went over that, it might become a little bit more confusing for you. For today, you are on your first step. You know what? Let me show that to you. First, think of this as a bandana pattern, and think of like this bandana being in front of you, bro. Now, what do you do when this bandana is slightly skewed towards the other space, right? Like this is the perspective thing. What happens to that bandana? Well, the patterns are going to remain relatively the same, and what happens is, no, I did the pattern wrongly. Oh shit. Yep, so this is like 1 2, and the same angles go here and here again, and the same angles go here and here again. And now you have the same bandana. This and this are like the same shit, although I shaded the wrong side. Stupid old me. They essentially work the same way. And that is how you measure distances in the perspective grid. And if you're like, what the is the perspective grid? Well, I taught that to you earlier. We can make the same inference again. If like all parallels line up at one point, to draw a square, how many set of parallels do you need? Well, let me draw a square. This is a square, and there are 4 edges for it, and each other edge is parallel to each other edge. Like this guy is parallel to this guy, and this guy is parallel to this guy. And now what we're gonna do is we're gonna need 2 parallel lines, right? We got those 2 parallel lines. We're gonna need 2 more parallel lines. Now we got them. What do we do with them now, you ask? Well, we essentially meet them up, and that becomes somewhat of a rectangle. Not essentially a square, but you get the thing. I didn't really teach you how to measure squares and stuff like that. That's more of something you'll be learning in mastery. Right now, to break down images, this is something you can use. And look at this. This is a good square. But what if it could be more? What if it could be a cube? Well, we know that inside of a cube, when we draw a cube like this, each side, and it's like a rotational pattern, is like parallel to each other side. Like see this, like this guy is parallel to this guy, who's parallel to this guy, who's also parallel to a hidden buddy over here. And what do they all do? They form a shape. So just as we made 2 sets of parallel lines and 2 more sets of parallel lines, sorry, 1 set of parallel line and 1 set of another parallel line group, and we converge them to make a rectangular box, we do the same but with 1 more point. Let me show you. This is the third vanishing point, and this is where we draw our third source of power from. And you know how we had one hidden buddy, right? We don't really have to show him unless we are making the object transparent. And that is mostly a benefit for us, because sometimes you don't line it up correctly and it still looks like a cube, and if you were to show the other side, it would look horrific. And yep, we have dealt with making a cube in perspective. You have learned what perspective is. We did a lot of things today, and let us actually take a second to appreciate what we learned. We learned perspective today, brother, and this, my friend, is actually a very big concept that not many people get to learn. Let me teach you something else too today. I'm gonna teach contouring to you. This is the art of war for art, but it's not war and it's contouring. Let me show you what a contour is. So, you know how cricket balls, when you like spin them fast and they like go towards the stump or something along those lines, they always end up looking a little bit skewed on the side. Although the line, when you look at it on the front, is straight. That is exactly where contouring comes into play. So when you look at this thing in D3, what happens is lines on it appear skewed more or less. And what happens then is your eyes think they are 3D. And now what happens when you put curved lines on a 2D piece of paper? Your mind still thinks they are 3D. And that is how the illusion of depth is actually constructed without perspective. And yep, that was one exercise. Now, how do you develop your contouring skills, brother? My stuff doesn't really look 3D. What do I do? Well, the question is, are you willing to practice? If you are, then I have a method for you. So, look at me, merrily drawing away this disco ball just because it's easy and I don't have to do a lot of hard work to make it work. And then now, look at me, making this little prism guy. What do you see there being common between the two? If I took away these, there is nothing left. So you can't really tell if it's 3D or 2D. And now when I put it back, your brain can suddenly comprehend it. And what you have to learn is how lines bend in a three-dimensional space. Like, say there is a surface here, and there's like a train track coming up. And now the train track goes down and it goes forward. And what you're actually seeing me do right now is contouring, pretty much. Because the train track is a straight line, and when it's put on different surfaces, it curves, right? So just like the train track, lines too curve. And that was the gist of contouring. With these two things you learned today, you'll be able to break down images to a greater extent. You'll be able to draw stuff better starting today. And maybe when you're ready and you've practiced all the stuff that you've seen today and you're able to draw boxes, you're going to want to do more stuff with the boxes. Like put stuff in there. How do you do that? Well, that's pretty simple. You just quite literally use these lines as references, or like think of these things as representation of the surfaces, right? So now think of these things like the representation of the perspective grid. Say I wanted to draw a head right now. I know the top part of the head is gonna fit into the top plane of this thing, and the bottomer parts of the thing are gonna fit into the bottomer planes, if that's even a word. And yep, so that is how you have to practice putting stuff in. You just have to think about these edges moving towards different places, and you're just gonna have to align them. And yeah, you learned a lot of things today, a lot of stuff for the brain to process. Process them, practice, just draw a shit ton of cool stuff, and then be back tomorrow, because that'll be more. I'll teach you how to draw landscapes and stuff then.